Hi everyone, in this video we're going to go over significant figures. We're going to look at the 5 rules that you can use to determine how many significant figures are in a number. Let's look at the first one. Non-zero digits are always significant. For example, 123 has no non-zero digits and therefore we have 3 sig figs. And the number 4,789, we also don't have any non-zero digits, and so therefore we have 4 significant figures. Let's look at rule number 2. Zeros between non-zeros are significant. For example, 102. The 0 is between 2 non-zero digits, and so therefore we would have 3 significant figures. Let's say we have 7,056. The 0 is also between 2 non-zero digits. So therefore, we have 4 significant figures. Rule number 3. Leading zeros are not significant. Leading zeros are those found to the left of a number. For example, in 0.005, these would be the leading zeros, and they are not significant, meaning that we only have one significant figure. Another example would be 0.03. We do not count these zeros before the number, and so we would also only have one sig fig. Rule number 4. Trailing zeros in a decimal number are significant. For example, 2.300. Trailing zeros are those to the right. In this case, we would have 1, 2, 3, 4 significant figures. If we had 4.00, because of that decimal place, we would have 1, 2, 3 sig figs. Trailing zeros in a whole number without a decimal place are not significant. For example, let's say we have 470,000. These trailing zeros are not significant. Therefore, we only have 1, 2 sig figs. If we have 1,500, we also wouldn't count these. And we would again have 2 significant figures. Let's look at some practice problems. You can pause the video here and then come back to look at the answers. In the number 12.34, we would have 1, 2, 3, 4 significant figures. In the next example, we wouldn't count these leading zeros. Therefore, we would only have 2 significant numbers. Here we would have 1, 2, 3, 4, 5 significant figures. We have a decimal and our zeros are in between non-zero digits. Here we have to remember that trailing zeros in a decimal are significant. Therefore, we would have 1, 2, 3, 4 significant figures. Remember, we wouldn't count the leading zeros. Here we have a whole number with no decimals. Therefore, these trailing zeros are not significant. So we only have one significant figure. Same goes for this example. We would have 2 significant figures since we wouldn't count that zero right there. Let's go over multiplication and division. The result should have the same number of significant figures as the factor with the fewest sig figs. Let's look at an example. If we have 5.678 times 0.0034, first let's see which factor has the fewest significant figures. Over here we have 1, 2, 3, 4. And here we only have 2 significant figures. Therefore, we know that we have to round our answer to 2 significant figures. If we multiply these, we would get 0.019305 2. Our first significant figure is 1. Now, we have to see if we can leave the 9 as it is or if we need to round up. That depends on the number next to it. If it's 4 or below, then we can leave it as a 9. If it's 5 or up, then we have to round up. Since the number next to it is a 3, then we can leave it as 9. Therefore, our final answer would be 0.019. Let's go over some practice problems. You can pause the video here and then come back to look at the answers. If we multiply 4.56 times 1.4, first let's figure out how many significant figures need to be in our answer. Here we have 1, 2, 3 significant figures, and here we only have 2. So our answer needs to be rounded to 2 sig figs. If we multiply them, we get 6.384. Our first sig fig is 6. Now we need to look at the 3 and determine if we round up or if we leave it as it is. Since the number next to it is an 8, then we have to round up. Therefore, our answer would be 6.4, and it includes 2 sig figs. In the following example, we have 1, 2, 3 sig figs here, and 3 sig figs here. So our answer needs to include 3 significant figures. When we multiply this, we get 0.0106704. Our first 2 significant figures are 1 and 0, and we have to determine what to do with the 6. Since the number next to it is a 7, then we have to round up, meaning that our answer would be 0.0107. And this includes 3 sig figs. Now let's determine how many sig figs we have in this problem. Here we have 1, 2, 3, 4, and here we only have 1. If we divide 100.0 by 3, we get 33.33333. Our first significant figure is the 3. So let's look at the number next to it and see if we have to round up. The number next to it is a 3. And since we only want one significant figure in our answer, we would leave it as 30. It would only have one sig fig right here, and that would be our final answer. Let's look at the last problem. Here we have 3 sig figs, and here we only have 1 sig fig. If we divide 7.89 by 0.005, we get 1,578. Now, we want our answer to only contain one significant figure. Our first significant figure here would be the 1. So we have to look at the number next to it to see if we leave it at 1,000 or if we round up to 2,000. Since the number next to it is a 5, then we would round up to 2, making our final answer 2,000, so that we only have one significant figure in our answer. Now let's go over addition and subtraction. This one is slightly different because the result should have the same number of decimal places as the number with the fewest decimal places. Let's look at an example. If we are adding 5.67 plus 0.0045, first we have to see which one has the fewest number of decimal places. When I'm working with addition and subtraction, I find it easier to line up the decimal places. I like to write it out like this instead. And so here, I know that I need to include 2 decimal places in my answer. So if we add this, we get 5.6745. This is where we would have our last digit. So we have to look at the number next to it to see if we keep it as a 7 or round up. If it's 4 or below, then we keep it as it is. Since the number next to it is a 4, then we're going to keep it as it is, meaning that our final answer would be 5.67. Let's go over some practice problems. You can pause the video here and then come back to look at the answers. Let's go over the first one. I'm going to rewrite it like this. And here I can see that I only need to include one decimal place in my answer. So if we add them, we get 1, 4 plus 1 is 5, 5 and 1. Since the number next to the 5 is a 1, then we don't need to round up our answer. So our final answer would be 15.5. Let's go over the next one. Here, I also see that my answer needs to include only one decimal place. So let's go ahead and add these. We get 5, 4, 3, 2. 2.345. Now let's look at the number next to the 3 to know if we round up or keep it as it is. Since the number next to it is a 4, then we leave the 3 as it is, and our final answer would be 2.3. For the subtraction problem, we see that we only have to keep our answer to one decimal place. This one has 1, and this one has 3. If we subtract this, we would get 45.356. And so this would be our first decimal place. Again, we look to the number next to it to see if we round up. And since it's a 5, then we do need to round up, making our final answer 45.4. Let's look at the last problem. Here we only have one decimal place, and here we have 2. So our answer needs to stay to one decimal place. If we subtract this, we get 96.8. And our answer already has just one decimal place, so that is our final answer. And that is it for this video. I hope that it was helpful for you. Make sure to like and subscribe.